The title of our project is Hardware Conversions and Standalone Cable Checker. Our team has four technical directors: Nathan Shake, a test engineer; Daniel Harnett, a test engineer; Al Binder, director test development and project engineer; and Christopher Keeble, senior PCB designer. Our team members consist of three electrical engineers: David Botello, Nicholas Petrozzi, and myself, Anthony Cepeda. Founded in 1981 and headquartered in Andover, Massachusetts, VICOR Corporation is a global power management company that designs, manufactures, and markets innovative power, modular components, and systems. The company is known for its expertise in power electronics, including modular power components, power distribution systems, and custom power systems. VICOR primarily operates in the power electronics and semiconductor industry, providing solutions for a wide range of applications, including data centers, industrial equipment, telecommunications, and more. VICOR has a reputation for innovation in power management technologies. Their focus includes advanced power architectures and system level solutions to address the challenges of modern power delivery. VICOR tests a diverse range of ICUs using automated test equipment and intricate PCB setups. Test designers, engineers often spend considerable time debugging issues that may arise in different stages. Our project aims to streamline the current standalone cable checker and making a finished product. Cable checkers are handy tools for technicians and electricians professionals who need to quickly diagnose cable related issues and ensure that the cables are functioning correctly within a network or system. This cable checker will test for continuity and shorts. Our anticipated best outcome is to create a custom-made PCB that revolutionizes cable testing. This compact yet powerful solution enables testing across multiple cable connections with precise and efficiency. The result is a finished product that facilitates streamlined debugging, minimizes downtime, and promoting standardized testing procedures. With our innovative PCB design, we ensure a robust and reliable cable checker that significantly enhances the speed and accuracy of cable testing, ultimately contributing to seamless operation of network and systems.
As
As
for our key technical accomplishments, we had two hardware conversion projects that have both been completed, Pro Bump and Pro Pad project. For these two projects, we were given a set of schematics and we had to swap out various components along with reconnecting components that were rotated 180 degrees within the schematic. For the standalone cable checker, we have already redesigned the schematic and have almost completed the layout for our three custom PCBs, the main board and two daughter boards that connect to the main board. For the economic impact of the company, the hardware conversions will reduce the overall production costs of each wafer. This is due to the testing time being nearly halved by eliminating map rotation during testings. As for the standalone cable checker, it allows for efficient cable testing. The tester will cut down on time and costs as it allows test engineers to quickly diagnose a cable and not allow them to use faulty equipment during production. Our block diagram shows our progression of the two projects. The first block, which is green, represents the two hardware conversion projects, the Pro Bump and Pro Pad projects that have been completed. For the standalone cable checker in orange, which is still in progress, shows the three PCBs being designed, the main board and two daughter boards. Once the boards are complete, we can start working on the Arduino code to make the tester work as designed. Once the code is implemented, we should be able to assemble the tester within its housing unit and deliver a final product. As far as my own technical contributions, I'll start with the hardware conversions. For each of the two projects, I had to update various resistors, capacitors, and relays on the schematic pages I was given. For the Pro Bump, I was in charge of updating the main page. And for the Pro Pad, I was in charge of updating the pulse and relay pages. As for the standalone cable checker, I am in charge of the redesign of the main board. Using multiplexers, a data selector device that selects between several inputs and forwards the input to a single output, and demultiplexers, a device that takes a single input and can forward it to several outputs, and an Arduino to control them, we will be able to automatically test the cables for continuity and shorts from pin to pin. As for my technical contribution goals, I need to finish the layout for the main board. Once we have printed boards, I'll take the lead on getting the main board to fit in the housing unit we selected above. The main modifications will be done to the top plate as we need to cut two areas out, one for the Arduino and one for the LCD. I will also need to expand the two slots for the connectors at the bottom as our new connectors are twice as thick. We also have various switches that will need to be strategically placed on the top plate where they would make the most sense to be. The goal is to have the housing unit fully modified and ready to assemble once the code is finished.
Here, I will be talking about daughter board side A. For the hardware conversion, I was in charge of updating multiple resistors, capacitors, and relays on two different projects, the Pro Bump project and the Pro Pad project. For the Bump project, I updated the post schematic page, and for the Pro Pad, I updated the main page. I also had to do research on a replacement for an obsolete component. For the standalone cable checker, I have redesigned cable side A schematic, which is one of two daughter boards that will consist of cable connectors. Cable side A has three connectors, two flat ribbon connectors, and one ITT Cannon connector. My goal is to tailor the PCB to precise dimensions, also to optimize routing the PCB, which I began the process. After I complete this process, we will order the board and I will begin the coding process on the microprocessor on the Arduino.
Here is our project's block diagram once again. Pay special attention to the highlighted area as it sets the stage for the standalone cable checker daughter board PCB side B, which I'll delve into shortly. I'd like to share my technical contributions to our Capstone project. We have completed the hardware conversions, which focused on the Pro Bump and Pro Pad projects. Similar to Nick and Anthony's contributions, I also updated various components in the Pro Bump and Pad project schematics, including resistors, capacitors, and relays. Moving forward, our primary focus is the standalone cable checker. Specifically, my responsibilities will be to create the daughter board side B, complementing Anthony's work on side A. This component is crucial in connecting wires during testing. Daughter board side B features champ ribbon connectors, while the daughter board side A incorporates flat ribbon connectors. This approach allows us to cover both connection ends, ensuring comprehensive coverage for the cables being tested. My schematic revision for the SCC cable side B is also complete, and I'm currently working on the PCB revision to bring this aspect of the project to fruition. My technical contribution goals involve tailoring the daughter board side B PCB to specific specs. Precise dimensions have been given thanks to Christopher Keeble, our senior PCB designer at VICOR. The next steps include optimizing routing and coding the standalone cable checker using a pre-established microprocessor. Once completed, I will assist with the integration of daughter board side B PCB into the CAMI Research M2 expansion cable tester case. As we look ahead, our team's future plans include routing all PCBs. Nick handles the main board. Anthony and I each contribute a daughter board. We've chosen the Arduino Mega for its capabilities over the Arduino Nano and Arduino Uno. Finally, we'll code the microprocessor and integrate and assemble all PCBs with a CAMI Research M2 expansion cable tester, ensuring a comprehensive solution. In our projects, we're mindful of potential challenges and have strategies in place to mitigate risks. Unexpected technical difficulties during the standalone cable checker development and PCB integration are addressed through regular reviews, comprehensive testing, and contingency plans. Integration risks are managed by conducting capability tests, maintaining a clear plan, and allowing buffer time. We're also focused on mitigating the risk of undetected issues by implementing thorough testing protocols, regular quality assurance reviews, and establishing a robust feedback loop for continuous improvement. These measures aim to systemically address challenges and ensure the project's reliability and functionality. We would like to express our sincere gratitude for the guidance and support we have received throughout our capstone project this semester. Our technical directors' expertise and passion were instrumental in our success, and we are truly appreciative of the invaluable experience we have gained. Working with such a dedicated and knowledgeable team at VICOR has been an honor, and we look forward to applying the skills and insights gained in our next semester and future endeavors. Lastly, a thank you to Dr. Sunak and Professor Mike Smith for this opportunity.